called Physics of the Moon Reflection, explaining why the reflected image of the sun in the Apollo astronauts' helmet visors is too large to be the sun's image, and therefore must be some type of studio light with a large parabolic reflector. While I was making that video, I discovered several other things that don't make sense, several other anomalies, and that is the reason for this video, to examine the mystery of the Apollo sun. Now watch this 30-second Apollo 15 video clip and notice that the sun's reflected image decreases in size, gets smaller over the course of this clip. Now here is the clip again. Now watch the brightness of the video. The brightness will decrease. And as the brightness decreases, the reflected image of the sun decreases also. The size decreases. When we look at the sun from the earth, it is a certain size. If we would look at the sun from the moon, it would be the same size as it would be if we looked at it from the earth. And that is because the moon and the earth are very close together, 250,000 miles, relative to the 93 million miles away that the sun is. So any slight changes in distance here would be only a fraction of a percent of the distance to the sun, would be imperceptible changes of size. But yet when we look at these images here of Apollo 15, we see that the sun does indeed change size. These two images are only about 15 seconds apart. And they are remarkable because the camera is aimed in exactly the same spot. It's impossible. Because the Earth and the Moon, 93 million miles away, sun doesn't change size. Now, if you watch the video, the brightness decreases as the sun's image decreases. And one might suppose that maybe that has something to do with the sun's image shrinking. But if you look at this image, now if we try to decrease the brightness and increase the contrast, the sun's image does not change size, the reflected image. We shouldn't expect it to change size. Just because we decrease the brightness, bright objects should not change size. But yet they do. And if you look at the surface of the moon here, it's actually brighter in this image than it is in this image. If you compare these two images, the sun's image does not change size. And we can see that the white here is darker than the bright here. The bright's here. And this is darker than here. The sun's image cannot change size. It's impossible. Okay, we know that the brightness of the video decreases over the course of about 15 seconds. Now, what could be the reason for this decrease of brightness? Well, it certainly is not the sun decreasing. The only possible explanation is that the camera somehow has something to do with this. Now, the camera used to make this video is an RCA J series. This camera had an automatic gain control, an automatic brightness control. And how that works, the circuitry computes the average brightness of the scene and adjusts the camera aperture accordingly, adjusts the exposure, so that the brightness is within, the average brightness is within a certain level. The problem is the AGC circuitry has to act very quickly, within fractions of a second. Otherwise, it's useless. It can't take 15 seconds to make an adjustment. This just doesn't make sense here. There is no good reason for the decrease in brightness over 15 seconds that fits the official story. There's no good reason. Okay, when we look at this image, it's very bright. Now, if we adjust the brightness and contrast, decrease it, we get something like this. And this is what it should look like if the camera's automatic gain control had decreased the brightness. But yet, this is what we get. We get this. Now, if you look at how bright the astronaut suit is here. But if you look at the lunar surface and compare it to this image here, they're about the same. We would expect the astronaut's brightness to be about the same, but yet they are not. The brightness here of the astronaut is significantly less than the brightness here. Now, the camera circuitry is not capable of selectively changing the brightness of certain areas of the screen. This almost looks like there's a spotlight focused on the astronaut here. Even though the overall image has been darkened, the brightness decreased. Even though it's been decreased, the astronaut still stands out very well. It's almost like his spotlight is focused. He should look more like this. It doesn't make sense. The circuit is not capable of doing that. It doesn't make sense. Now we have 4 impossible anomalies. Number 1, The sun's image changes size as the brightness is decreased. And number 2, the camera's AGC circuit, the automatic gain control, takes too long to decrease the brightness. And number 3, the brightness decrease is selective to certain parts of the scene. And number 4, I've talked about this in a previous video, the reflected light image is too large to be the sun. Now these are all impossible if we are to believe the official Apollo story. But maybe there is another story. Years ago, filmmakers realized the importance of proper lighting in making films and movies. Here we see a spotlight focused on actress Kim Novak in a 1960s movie. Lighting was very important. And of course, Hollywood could recreate any scenario. Here we see a scene from Capricorn 1, a movie about faking a landing on Mars. Now, if you look at these large studio lights here, you'll see there's a step ladder. You had to climb up a ladder to adjust these. These are very large lights. Now, Hollywood filmmakers needed lights that would have all the abilities to shape a beam of light any way they wanted. These lights had to be able to adjust the brightness and adjust the focus, adjust the sharpness, change shape, the ability to filter the light. Anything that they needed. They needed to be able to do anything they wanted with a beam of light. Okay, here we have a diagram of a studio light. We have a very bright light source here and an ellipsoidal reflector. Now right here, we have an aperture. And this aperture, also called an iris or shutter, you could change the shape of this, the size of this shutter. Now, if you decrease the size of the shutter, the light's brightness would decrease. And as you decrease the brightness, the size of the beam of light would decrease. And this would explain what we see in the Apollo video, where the sun's reflected image decreases in size as the brightness decreases. And we also have a focusing system here. Now this would explain how we can decrease the brightness of the scene and still maintain a nice bright image on the Apollo astronaut, a focused beam on the astronaut, explained by the lens system here. Now, the shutter adjustment can be adjusted in any length of time. You can adjust the brightness quickly, or you can adjust the brightness slowly. And this would explain why in the Apollo video, it takes over 15 seconds for the brightness to decrease. And also the very large, you can have a very large studio light, and that would explain why the reflected image in the Apollo astronauts' visors is too large to be the sun. Was a large studio light used to produce the Apollo cinema? Well, if you believe the official story, you have too many things that don't make sense. If you want to make sense of the things we've talked about here, then a large studio light explains the anomalies that we've seen. And without the studio light, the official story is impossible. And I think I'll end this video with a quote by that remarkable detective, Sherlock Holmes. And this is what he had to say about the impossible.
The door is locked, the window inaccessible. The grate's too small. How then?
You will not follow my precept. How often have I said to you that once you have eliminated the impossible, whatever remains, however improbable, must be the truth.